In exercise set 5 of module 5, this is actually something we should have worked on earlier, but we wanted to give you some background in general algebra before we started this, so we'll take a look at it now. So let's move it up, and what we'd like you to do is for examples 1 through 5, see if you can develop an equation, and then you're going to get a quadratic equation, put it in standard form, factor it, and see what you get for answers. So we'll give assignments 1 through 5. You're just going to work on one, and then we'll see how you did. Let's pause. So we'll do this in steps. This should be your equation that you developed from just reading the problem. And here I would suggest a diagram. Length times width. And the width is 5 times, the width is W, the length is 5 times the width. So there is your equation. So we'll pause, we'll put these in standard form. Just transposing where I need to get all the terms on one side, equaling it to 0. So these are now in standard form. You'll get a chance to check your work. We'll pause. Okay, now what we want to do for all of these is factor them and find the zeros. So we'll get back and let's see how you factor them. Now this is the next challenge to see what do they factor into. And again, I had to pause and spend time working on these. For number 1, it's 11 and 12. 2, 6, and 5. That one was easy. 3, 10, and 11. That one was sort of easy. This one was a little hard. 21 and 20. A strategy when you have a number like this and there's only a difference of 1 is take the square root of that. Square root of 400 is 20, so it gives you sort of an idea of where to go with it. And then for number 5, I would divide everything by 5, and then I get the difference of perfect squares, which factors into its conjugates. So let's see if you can get the signs correct and get these answers. So, checking the signs, here our negative is 11, 12 is positive, 6 is negative, 5 is positive, 10 is negative, 11 is positive, 21 is positive, 20 is negative, and for 6, I should say 5, you get a positive and a negative. Now I've left out the letters. You would put that in there. So now, what would the answers be? Well, since we can only take, well, it depends on what they're asking. It's going to be opposite signs. So this one would be a positive 11 and a negative 12 would be satisfactory answers for number 1. And again, basically it's just opposite signs for all of these. So this would be a positive 6 and a negative 5. Now here when we have consecutive numbers and we're looking for page numbers, it would be a positive 10 and we just reject this one. There is no page -11, but 10 plus 1 is 11. So for this one, our answers are 10 and 11. And for this one, again, facing pages, it would be the negative value that we convert to positive. So our page numbers are 20 and 21. And for here, the front porch is going to be 6. And then this would be 5 times 6 is 30. So looking at our rectangle of the front porch, 30 times 6 is 180. So again, as you put your answers into MATLAB, some of these you may be able to figure out just using arithmetic, but in your work for your final exam, you need to show the equations, show how you put them in standard form, show the factoring to get your answers. And having your answers of the ones that you select meet the qualifications of the questions they're asking. So here they're going to find dimensions, so your numbers need to be positive. Book pages need to be positive. Parking spaces, positive. But in examples 1 and 2, you get 2 answers, one positive, one negative, and they both work as answers. Okay, we'll keep this a little short.